Hello?
Hello, class. We're about to start section 2A, Keeping Current. Our learning objectives is to decide on an appropriate type of model for a given data set, model data with a linear or exponential equation, and research current data to compare it to values predicted by a model. To me, the real state of the union is found in how Americans react to current events. Henry Rollins. Okay, now, at the bottom here, it says if you're like many students, you're concerned with the cost of attending college. It's certainly not a secret that college tuition has been rising rapidly over the last 20 to 30 years. But what are the facts? For that, we need some data. The following table lists the average cost of tuition and required fees for all four-year American colleges and universities for a variety of school years starting in 1980. Now, you see this starting from 1980 all the way to 2017. They were first going up by 10 years, and then they started going by 1 year after 2010. Now we go here to the back. It says to analyze the data and look for patterns, we've seen that scatter plots can be useful tools. We've also seen that when modeling data based on time, it's a good idea to choose input values based on time passed since the first data value we have. In this case, we should use inputs that correspond to the number of years since 1980. So it says fill in the table of values using the information in the last table. Your X value should be years since 1980, and your Y value should be the average tuition cost for that year. Okay, listen. If we look back here, we see we got 80, 90, 2000, 2010, all the way up to 2017. So since it's 1980, it'll be 0, 10, 20, 30, 31, 32, 33, 34, 35, 36, and 37. And remember that's since 1980. So then we will fill in the values that we need to fill in here. Sorry, my camera froze, but that's fine. So we will fill in these values here, and we will fill in the corresponding amounts. Okay, we will fill these in. Okay, let's see. All right, it's quite a bit of numbers here, but we're almost done. Okay, so we have these values. Now we go down here to the bottom. It says draw a scatter plot of the data in your table. Make sure you choose an appropriate scale for each axis and clearly mark the scale on your graph. Okay, so now if you notice here our X values is years since 1980. And so we go from 0 to 37. So what we need to do here, if we look at these lines here, there are approximately like 40, well, about 39 tick marks. So we could go by ones, but we could go, this would be 0, 1, 2, 3, 4. We can go by each 5. Okay, so now we have our values here. So now we go down the side here, which is the Y value, which is the tuition and fees. We know we'll start here at 0, and our tuition and fees start at about 1679 and goes to 15,924. So what we could do is go up by thousands because it's about 16 tick marks here, 16 or 17 tick marks. So if we go by thousands, We could go 1,000, so this would be 2,000, 3, 4,000, 5, 6,000, 7, 8,000, 9, 10,000, 11, 12,000, 13, 14,000, 15, 16,000, and then we know that would be 17,000. Okay, so now we filled in this table. Now we want a graph. Okay, so we look here at 0 is 1679. It'd be very close to 2,000, a little bit above half. Okay, then we go to 10 years. At 10 years, it was 4,009. So if we look here at the 10-year mark, we'll just go slightly above the $4,000. Okay, now we go here to the 20-year mark. At the 20-year mark, we have, what's that, 7,372. So we got, let's see, this is 7. It's almost half. Okay, then we go to the 30-year mark. At 30 years, we have 12, almost 13,000. So we'll go up here. So it'll be almost 13,000. And then now we will go to 31 through 37. So 31 would be, what, a little over 13 and a half. Should be about here. 32 would be about 14,000, a little over 14,000. 33 would be the halfway point between 14 and 15,000. 34 will almost be at 15,000. 35 would be almost at the center between 15 and 16,000. 36 will be about the center. And then 37 will almost be at 16,000. All right. So now we have our scatter plot. It says here, based on your scatter plot, which type of equation do you think will most appropriately model the tuition data? Linear or exponential? Explain your answer. Okay, so your answer might vary. And we were talking about here with number 3. Your answer might vary here, but I could say that what I notice here is like curving. You look here, it looked like it's curving a little bit, but then it also looked like it could do the straight line. So I probably would say it looks more linear. It looks more linear when the years are closer. Okay, number 4. It says, using a graphing calculator or a spreadsheet, find the linear equation of best fit for your data. All right, so we want to put this into the Desmos calculator. So we'll hit our plus sign, we'll hit our table, and then we would type in these values. Okay, so I entered in these values and we look here. We want to change this to a linear equation. So let me see first. Ooh, I would have to, okay. It almost looked like a straight line because I didn't change the window. But let me see if we're going to need the window. Okay, so we would do y sub 1, and then we have to do the tilde. And then we have mx1 plus b. And it gives us the linear equation. Now, they want us round all coefficients so that they have 5 digits total. So we have y equals, the slope is in 5 digits, so we'll put 414.94x plus the b, we have to round to 2 decimal places to get 5 digits, so it'd be 574.80. So that would take care of that. All right, now it says 5, graph the line of best fit and your scatter plot on screen. Based on the graph, how well do you think your model fits the data? Explain. All right, let me change this wrench here. Let me change these values. We went anywhere from 0 for x all the way, I'll say, to 40. All right, for y, we'll go anywhere from, I'll just say 1500 all the way up to, what was the highest amount? What? We can go to 17,000. All right. Now, if we look here at this graph, this is our line here, best fit. You see the graph here, like we were told to do. It says graph the line of best fit and your scatter plot on screen. Based on the graph, how well do you think the model fits the data? Based on the graph, it seems to fit well because it hits a lot of the points. Now it said here based on the graph. Now if we look here at number 6, it says, what is the correlation coefficient for your equation of best fit? So the correlation coefficient is the R value. So it's R equals 0.9915. It says, does this change your perspective on how accurately the model fits the data? Well, it just verifies what I thought. Because the correlation coefficient is very close to +1. So it basically verified what I thought, that it was a good graph. Okay, number 7, write a description of what the slope of your linear model tells us about the growth of tuition since 1980. Okay, so basically be very specific. The tuition rate increases at an average of $414.94 per year since 1980. Now it says, now use your calculator or spreadsheet to find the exponential equation of best fit for the data. Now remember, we went over the exponential equation is y equals ab to the x. So we will put that in here. It'll be y sub 1 is equal to ab, and then we would take this to the power of x to the x1. Oh, and you know what? We weren't supposed to use the equal sign. We were supposed to use the tilde. Okay, now we have the tilde here. Now here's the thing. Whenever you do an exponential regression, you must hit this log mode box, and then it will give you the correct answers. So remember, with exponential regression, you must hit this log mode box. So they ask us, say round all coefficients so they have 5 digits. So we have y is equal to 1,976.3, that's 5 digits. And b will be 1.0617, 5 digits to the x power. Now it says graph the exponential equation of best fit and your scatter plot on screen. Based on the graph, how well do you think your model fits the data? It's the same data, but what I'm going to do, I'm going to turn off the linear so we could just look strictly here at the exponential. It looks pretty good. So we could say it looks pretty good and is almost as good as the linear equation. Because it hits most of the points. Now, we come here to number 10. It says, write a description of what the base of the exponent in your exponential model tells us about the growth tuition since 1980. Okay, if you look here, this is the base here. Now remember, to find out the percent that it grows by, we have to subtract 1 here, and it's really like 6.17%. So we could say the growth rate of tuition is about 6.17% per year since 1980. Okay, now go here to problem number 11. It says, what is the correlation coefficient for your exponential equation of best fit? Does this change your perspective on how accurately the model fits? So the R value, correlation coefficient, is 0.991. All right. And I would say it confirms what I thought, because the linear equations correlation coefficient is slightly higher, making it the better graph. Now, number 12, it says, based on all of the work we've done in this portion of the lesson, which model do you think is the best choice for modeling the tuition data in the table? It would have to be the linear equation because the correlation coefficient is higher. Okay. And that is basically it from section 2.8. If you have any questions, feel free to contact me. Have a wonderful day.